Hi, welcome to my video on proofs with overlapping triangles. Proofs with overlapping triangles. Let's do some examples. We're given that AC equals DB, AC, which is this segment, equals DB, which is this segment, and we're given that AB is perpendicular to BC, and DC is perpendicular to BC, and we have to prove that triangle BXC is isosceles. In order to have an isosceles triangle, we must have two sides equal. So these looks like the two sides that are going to be equal. So we have a choice to do these two triangles, which are A, B, X, D, C, but the only thing we have here is that we have this angle equal to this one, AXB equal to CXB by VOAT, vertically opposite angles, but we don't have any sides equal. So we'll have to try another pair of triangles. So let's try the big triangles, which is A, B, C, and triangle D, C, B. Let's try these two triangles, and you can see that they're overlapping, the big ones. We're given that AC equals DB. We're given the perpendiculars here, and I also see that BC equals CB, common side to both triangles. So these triangles are congruent by, can't say the angles are equal because they're right angles. We can use the hypotenuse leg because that's the hypotenuse opposite the right angle, and that's the leg. So once the triangles are congruent, then we can pick up that this angle 1 and 2. So angle 1 is right here, angle 2 is right here. Because these triangles are going to be congruent, 1 will equal 2, which is right here, and that means these sides will be equal by converse of ITT, and the triangle is isosceles by definition. So let's write that proof up. Here we go. Number 1, AC equals DB, given. Number 2, AB is perpendicular to BC, and DC is perpendicular to BC, and that's a given. Number 3, we have that angle ABC and angle DCB are right angles. Definition of perpendicular segments or lines. Perpendicular lines form right angles. And remember, we can't say, if we say the angles are equal, then we're looking for the triangle to be an ASS. We can't use an ASS, so what we have to do is say that triangle ABC and triangle DCB, triangle ABC, DCB are right triangles. That's the definition of a right triangle. Now, I already have these two sides equal, so I have BC is equal to CB, common side. BC is in both triangles here and here. That's common side. And that means we have the triangle ABC congruent to triangle DCB by hypotenuse leg. because this is the hypotenuse in this triangle, and that's the hypotenuse in this one, and these are the legs, they're equal, and that makes, we can see that makes, and I have angle 1 equals angle 2, CPCTC, corresponding parts of congruent triangles congruent, and that makes, now we look back at because they're overlapping, if angle 1 is equal to angle 2, these are equal in this triangle right here, so I just put down, that's the triangle BXC. These angles are equal, just to let you know. That means that BX equals CX by converse of ITT. These two angles are equal in this triangle BXC, so therefore these sides are equal. And that makes the triangle BXC is isosceles. And the reason is definition of an isosceles triangle. Why? Because two sides are equal, triangles isosceles. Okay, let's have a look at B. Let's do this proof. Again, you can pause the video and work these out before I do them to see if you're going to get them right. But sometimes your reasons might not be in the same order as mine, but at least you see how to do it. So we have PS equals RQ. We have PQ equals SR. And we got to prove that PS is parallel to QR. And to prove parallel lines, I need let's go backwards. If these lines, if PS is parallel to QR, that means that that angle is equal to that one, or it means that that one is equal to that one. So I have to get one pair of these angles equal. So let's look at the triangle TSQ. Let's look at these. Let's see. TSOQR. Let's look at these two triangles. And the only thing we have equal here is we have no sides equal, because PS is equal to QR, and that's a TS and QR is a part. Oh, that's a, sorry. STSO and QOV. That's a little here there. That's a V there. These two triangles right here. And so we have no sides equal, but only these two angles right here. So that's not going to be good to use. So let's look for another pair. And we have PSQ. And we have PSQ. So we have QRS, which is this one, QRS. Notice I'm drawing them separately so you can see it. Now I can't use these two, I'm going to use these two. Let's see. I have PS is equal to RQ. I have PQ equals RS. And notice that QS and SQ are common to the two triangles. So the triangles are congruent by SAS, and that means that, and I'm going to look at these angles. This angle, let's name this angle 1 and this angle 2. So let's put 1 right there, put 2 right there. So because the triangles are congruent, angle 1 is equal to angle 2. Notice in the diagram, angle 1 equals angle 2. Therefore, the lines are going to be parallel by converse. So let's write that proof up. Number 1, PS equals RQ, PQ equals RS, given, and we have SQ equals QS. Notice that PS equals RQ, so this angle here, S, goes at the angle Q. So it's SQQS, and that's a common side to both triangles. And that means I have the triangles P, Q, S, congruent to triangle R, S, Q. P, Q, S, R, S, Q. And the reason for that is side, side, side congruency. And as a result, we have angle 1 equals angle 2. Angle 1 is equal to angle 2. And that's corresponding parts of congruent triangles congruent. And because those two angles, now look back at the main diagram, there's the two angles right there. There they are, right there. Because those two angles are equal, that means that PS is parallel to RQ, and it's two angles equal lines as converse of the PLT. And these angles are forming a Z, so it's alternate interior angles equal. Okay, so we have a couple of proofs done. And don't forget, at any time, you may pause your video and work the proofs out yourself. Let's try these two. I got two on this page. Given that angle 1 is equal to angle 2, there's angle 1 equals angle 2. Given that TF is equal to PE, notice they're overlapping a bit here. And we have to prove that the triangle TAF, which is this one, is equal to PAE, which is this one. So notice there's an overlapping here. So because I have 1 equals 2, I can get AE equals AF, converse of the ITT. I can get angle 3 equals angle 4 by SAT, but then I can't get any, 3 is equal to 4 here by SAT. I could subtract EF from TF, and EF subtract from PE will make TE equal to PF, so I get TE equals PF, so I could have the triangles congruent by side, angle, side, but I would have to add these angles together. So I see a better proof to do, and the better proof to do would be to go ATF going with AEP. Let's try these two. They're overlapping. Notice that angle 1 equals angle 2. So that makes AE equal to AF by ITT. Notice that we have TF is equal to PE by given. And notice that we have angle 1. There's angle 2 right there. AFT. AFT is angle 2. AEP is angle 1. So these two triangles are congruent by SAS congruency. And that makes, notice the angle TAF, which is this angle right here, is going to equal angle PAE. So the big triangles are the ones we're going to do. So angle 1 equals angle 2, given. As a result, I have AE equals AF, converse of ITT. If two angles of a triangle are equal, the sides opposite the angles are equal. Converse of ITT. And we have TF equals PE. That's given. And we have the angles. So now we have, let's look at it. Angle 1 equals angle 2. The two sides are equal given. And these two sides are equal. These are two sides, sorry. TF is equal to PE given. AF is equal to AE by converse. So these two triangles, let's name them triangle ATF is congruent to APE. And that's a side angle side. So angle A goes with angle A, right? F goes with E, F goes with E, so P got to go with T. P goes with T. And that makes the angle TAF equal to angle PAE. Angle TAF equals PAE. And CPCTC. Congruent parts, congruent triangles, congruent. Okay, let's have a look at, again, don't forget you can pause the video if you wish. Now we have another proof to do. AM equals AT, so AM is this segment here is equal to AT, which is this one here. That's a given. We got AC is a perpendicular to BE, so that's a right angle here and a right angle here. We got AC bisects angle BAE. AC bisects BAE, so it makes this angle equal to this one. And I have to prove that 1 equals 2. So I have to somehow get a pair of congruent triangles. So it looks like I have to deal with AMC and ATC because these two are equal. These two angles are equal by bisector. AC equals AC, common side. So this triangle, ACM equals ACT by side angle side. And that makes these angles, I'm going to name these angles right here. Instead of using 3 letters, I use these angles 5 and 6. So 5 equals 6 by CPCTC. And because these are perpendicular, these angles ACB and ACE are equal. Therefore, take away 5 and 6 and you'll get angle 1 equals angle 2. So let's have a look at the proof. AM equals AT. And let's put the two givens into 1 this time. Don't forget to ask your teacher if you're allowed to do that. And because we have perpendicular, let's see. I have AC bisects angle BAE given. I could put all the givens in 1, but because that's a bisector, I left the segment separate. And then I'm going to say angle 4 equals angle 3. Definition of an angle bisector. And I have AC equals AC. Common side. And notice I have two sides equal. This is common side with this angle. So I have triangle ACM congruent triangle ACE, and that's an SAS congruency. And as a result of that, I have angle 5 equals angle 6, CPCTC. Corresponding parts of congruent triangles are congruent. And because of the perpendiculars that we have here, that makes the angle ACB equal to the angle ACE, because perpendicular segments form congruent or equal adjacent angles. And angle ACB equals angle 1 plus angle 5, and angle ACE equals angle 6 plus angle 2, and the reason is angle addition postulate. And because these are equal here, ACB, ACE, there they are, then we have that angle 1 plus angle 5 is equal to angle 6 plus angle 2 by transitive property. Of equality. Again, number 7 says these two angles are equal. There they are right there. So these are equal by transitive property. Because 5 is equal to 6, in number 10, I have that angle 1 is equal to angle 2 by subtraction. Subtraction property of equality. And that's another proof done. Okay, we have one more to do on the overlapping triangles. Here we go. And let's see what we're given. We're given that 1 equals 2. Okay, I can see if 1 equals 2, it's a possibility that this angle right here could equal this one, because this is a linear pair, this is a linear pair, and these are supplementary, so these two angles are equal by SAT, supplements of congruent angles are congruent. I have XY, which is this long side here, equals XW, which is this one here. So it looks like they're overlapping. So first of all, and I got to prove that YV, which is this long side here, is equal to WT. So I've got two long sides here with these two long sides. So it looks like I have overlapping triangles. But before I look at that, let's look at these two just to see. I have T, Y, V, W, and I do not have them intersecting. I have no letter here. So even if I did, this angle right here would equal this one. These two angles would be equal by VAT, but I don't have any more sides. So what I have to do is look at X, Y, V, X, Y, V, and I have to look at X, T, W. X, T, W. So what happens? I have, now I got to get these angles. So I have XY equals to XW. Okay. Notice that this angle right here, X, this angle is common to both triangles. First time I've done it with a common angle. Angle X is in both triangles here. But I need another angle. But notice I said that 1 equals 2, so let's put 3 here and 4 here. Because these are equal, because they're linear pairs, these are supplementaries, straight angles, and therefore 3 is equal to 4 SAT. So 3 is at T, 4 is at V. So these angles are equal. So I have an angle, angle, side, angle, angle, side. So 4 is going to equal 3. Triangles are congruent, and I have these YV equals WT. So proof is put together, which you should always try to do first. So here we go. Angle 1 equals angle 2 given. Angle 1 and angle 3 are a linear pair. Angle 2 and angle 4 are a linear pair. And the reason, definition of a linear pair that you've seen in previous proofs. A linear pair are two adjacent angles that form a straight angle. And as a result, angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 4. And the reason is we have a straight angle. There's a straight angle here, 180 degrees, that are supplementary. Notice that 1 equals 2. Therefore, angle 3 equals angle 4. It's called the supplement, SAT, supplement, SAT, supplement angle theorem. Supplements, these are supplementary, these are supplementary, supplements of congruent angles. These angles are equal, so these angles are equal because they're supplementary. And now we have angle X equals angle X. Now, not only, this is a common angle that's in each triangle. X is in both triangles. And now we have, do I have the sides equal yet? No, I've got to get the sides equal. So XY equals XW given. And let's see. So we have, here we have X is equal to X, 3 is equal to 4. These sides are equal. So now I have triangle XVY. And X goes with X, V goes with T, and the Y goes with the W. And that's angle, angle, side. Angle, angle, side congruency. And that makes it that YV is equal to WT. And its corresponding parts of congruent triangles congruent. So that brings us to the end of some proofs on overlapping triangles. And if you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.